Hi there, this is Courtney and Emmy, and this is our homework for Engineering460. So for this problem, we're basically just looking at a single server queue, and we're interested in the wait time between customers. So part A tells us that we're showing that our wait time equals the max of either 0 or this equation. So it'd be 0 if the service time is faster than the customer arrival time, and then this equation here is saying that the customers are arriving basically faster than we can service them. So that's definition of wait time. So part B is just basically we're looking at a Poisson process, and we have the arrival rate, which is lambda, and the service rate, which is mu. And then for part C, we're just going to experiment with different values to simulate different traffic intensities. So we're going to change the value of lambda to figure out which traffic intensities, like where we can get a stationary behavior even though we have different intensities. So here's our code, and the code satisfies part A and B with that Poisson arrival rate, where we have 1 over lambda as the arrival rate, 1 over mu as the service rate. And so here we have n equals 5,000. That's our number of iterations. We're initializing our variables here, and then we have it plugged in. That equation right here is plugged into a for loop, because since we're generating random numbers with our simulation, we want it in a for loop to get a lot of different iterations so that we can get that expected value of the average wait time and the standard deviation of that wait time. So that covers part A and B. Now for part C, we have different numbers that we can experiment with. So for the first one, we'll go with 0.5. and we'll run it, and we see that it is in a stationary process. So for that one, our expected average wait time is 1.0174, and our standard deviation is 1.7892. Obviously, since we're working with a simulation and random numbers, if I run it again, they'll be slightly different. But now we can go and let's change this to 0.95 and see what that looks like. So this one is slightly off from being a stationary process, so let's choose 0.99 and see what that looks like. Yeah, so again, it's kind of off, so maybe let's try increasing our number of iterations from 5,000 to 10,000. Okay, so we see here that it kind of is going back to that stationary thing, just because we have, peaks and pits of it, but they kind of are all evening out here, even though we have this like big leap here. So still not the best, but it's better than the last one. So for that, our expected average wait time is 85.7278, and our expected standard deviation is 48.8925. So now we are also asked to look at one that would never be stationary, like have stationary behavior. So that basically should be anything that's faster. So our arrival rate is faster than our service rate. So we'll run that, and you'll see here that it doesn't reflect that stationary behavior just because it is faster than we can service the customer. So for that, our expected average wait time is 929.7675, and the standard deviation of that is 522.3554. Thank you so much for watching.